Hello everyone. In this video, we are going to discuss another problem of the Taylor's method, that is from our numerical solution of ordinary differential equation. So here is the first question. In the second problem for using Taylor's method, solve dy upon dx equals to 1 plus xy with y not equals to 2 here, and find first one, that is y of 0.1, then 0.2, y of 0.3. So let's go. Here we are going to see. Firstly, the Taylor's logarithm is y naught equals to y naught plus h upon 1 factorial into y naught dash plus h square upon 2 factorial into y naught double dash plus h cube upon 3 factorial into y naught triple dash, and so on. So here x naught equals to 0 by default and y naught equals to 0 as given in the equation or the problem, and h is equal, firstly we are finding for the first one, that is 0.1, h equals to 0.1 here. So for the first, that is first order, that is y dash equals to dy by upon dx, that will be equals to 1 plus xy. So that is the first, and then overall after differentiating we are going to see second and third. So here it is, firstly y double dash d square upon d square of y upon d of x square, that will be equals to 1 plus xy. After differentiating this term, we are going to see dy ds of 0, that is 1 equals to 0, 1 will be automatically, it will be 0 here. So next one is divide over dx of xy, that will be equals to, firstly we are going to use protection rule, the chain rule. So that will be x as it is and y will be differentiated, that is y dash plus y will be as it is and x will be differentiated, that will be x is equals to 1. So that is x y dash plus y. So now the third one is y triple dash, that is dq upon dqy upon dx cube, that is so divide dx of the second term. So that is here. So after differentiating the first term, we are going to apply the production rule here. So that will be x will be as it is and y dash will be differentiated, so that will be equals to d double dash plus then y dash will be here, and x, the differentiation of x with respect to x, that will be equals to 1. So that is here, and the differentiation of y will be y dash. So they both y dash will be added, so that will be equals to x double y dash plus 2y dash. So next we are going to find out what are the values of the uh, y naught dash and y naught double dash, y naught triple dash. So let's see. Here it is. So first one is y naught dash, that is equals to y naught of x naught and y naught. So here it is. We have just as we have already find out x naught y naught dash y triple dash. So we are just going to apply or change it x into x naught and y into y naught, and then put the value of x naught and y naught. So the first one is 1 plus xy, that will be equals to x naught y naught, and x naught, the value of x naught equals to 0, y naught equals to 2 here, and 0 into 2 is equal to 0 and the 1. So the 1 will be answer here. The next one is y naught dash, that will be equals to double dash. So y double dash equals to x naught y naught. Applying here x equals to x naught y naught plus y naught. So y naught is already 2 here, and they both will be equals to 0. So the answer will be true. The same in the third term, we see y naught triple dash equals to y triple dash equals to a of x naught y naught. So we are going to apply y naught x naught y naught, that will be equals to 0 since x naught is already 0 and y naught equals double dash equals to 2 here. Y naught double dash equals to 2 here, so that will be apply here plus 2 y naught dash. Y naught dash is equals to here 1, so y naught dash 2 into 1, that will be equals to 1. So after evaluating all this, we are going to use this values in the above Taylor's algorithm. So y naught is as given is 2 and h equals to 0.1 into 1 factorial plus 0. H square is equal to 0.1 square, then 2 factorial into 2, this both will be cancelled. So 0.1 cube into 2, that is y, that is y triple dash, and divide by 3 factorial. and we don't need to add other terms. So after calculating it with the calculator, we're going to see that our answer is equals to 2.1103. Since this is the first part, let's see the other part as y of 0.1 is equal to 2.1103. So let's see for y of 0.2 and y of 0.3. So for the second term, y of 0.2, we are going to see y2. That the first second term, this will be equals to y2 here. This is other type of problem. The first type of problem, we are just needed to find out the first term. So we have to find out here y2 and y3 as well. So y2 will be, so the next one will be y1 plus h, and in the all this term we are going to see for the y1 dash, y1 double dash, y1 triple dash, and the values are as it is. So this is the value of Taylor's algorithm. Now first we are going to find out of y1 dash. Y1 dash will be as it is. Same we have to apply for y dash into x1 y1, that will be equals to 1 plus x1 y dash. We are just also just replacing x and y with x1 and y1 here. So let's see. So after applying this value, we are going to see x1 is here, x1 is x naught plus h. So x naught is already 0 and x and h is here 0.1. So we are going to put 0.1 in the place of x1 and y1 equals to the value of y1 we have evaluated after evaluation the Taylor's algorithm where we obtained 2.1103. So after calculating it, we are going to see 1.21103. Next one is y1 double dash. Again, we are going to change the value x and y with x1 and y1. So we get y1 plus x1 y1 dash. So and just putting the value of y1 the value of the y1 as we have calculated previously 2.1103 plus x1 is here just upgraded to 0.1, and here y1 dash the value of y1 dash is equal to 1.21103, that is in the above approximation. And the next one is y1 triple dash, that will be same, we are just upgrading x to x1 y to y1 or replacing it. So we will get 2 y1 dash plus x1 y1 double dash. So we just need to apply that value 2 y1 double dash 2 into 1.21103, that's one, and x1 the value will be upgraded to 0.1, and x1 double dash, that is, oh, sorry, y1 double dash the value is just here. So we're going to put this 2.2314, we will get 2.6452 here. So next we just need to put this value in the Taylor's algorithm. After putting this value, we're going to see that is the y naught here h and 1 factorial, and this term is y1 dash, and this is h square 2 factorial, and y1 double dash plus h cube 3 factorial. This one is y1 triple dash. You will just remember it after applying 2 or 3 questions. So y of 0.2 will be equals to 2.2430 here. Now going to the third. So the third approximation for y of 3 is equals to y of 0.3. So we are going to find out y of 0.3. So firstly, we have to apply y of 3, and then the next term will be y of 2 and plus h, and all this term will be as it is, and y will be upgraded to y2 of double dash, y2 of, sorry, this is just one dash, this is double dash, and y2 of triple dash. So we are going to do the same things here for y2 dash, y2 double dash, y3, y3 triple dash. So again replacing x with x2, y2, x2, y2, x2, y2. So we'll get 1 plus x2, y2, y2. So x is here, 1 is 1 as it is, and x2 will be 0.1 plus 0.1. Since we see that x2 will be x1 plus h, and h is 0.1, and x1 is already 0.1 here, so that will be evaluated to 0.2. So here we see 0.2 and the value of the y2 as we have calculated there, we get 2.2430. You just need to take the approximate value up to 3 decimal or to 4 decimal. So next, after calculating the value, we are going to get 1.4486. Next value is y2, x2, y2 dash. So y2 will be evaluated as it is, and x2 will be 0.2, and the y2 dash, that in the above approximate value, we get 1.4486. After calculating this with the calculator, we'll get this one. The next one is same here, and we are going to put this value just 2y2 dash plus x2 y2 dash double dash and 2 and y2 dash, the value that will be here, and x2 will be as it is, and y2 double dash just we have calculated here. So after putting the value, you will get 3.403744. Now we need to just put this value in the y3 value. Here it is the Taylor's expansion. So after putting this all value y2 and h, y2 dash, h square, y2 factorial, y2 double dash, and h cube, 1 3 factorial, y2 triple dash, and so on. We don't need to go further. After evaluating all this value, we are going to get 2.4011. That will be our answer for the y of 0.3. So that is all answer. Thank you.